Hi, sixth graders. This video is the third video reviewing for your final exam on Module 2 topics, which deals with operations with fractions and decimals. Remember, the best way to watch the video is to pause at each question and try it on your own first using a whiteboard or a piece of paper, and then unpause the video to check over your work along with me solving it and check that your final answer is correct. All right, so our first question here is for the end of the year flyers on the run race. Mrs. Dubish will place a course marker every 50 feet and a water stop every 70 feet. What is the shortest distance? So I just want to underline that. What is the shortest distance a runner will have to run to see both a trail marker and a water station at the same location? So shortest distance wouldn't be greatest common factor. Shortest would deal with least common multiple, or LCM. So I'm looking at every 50 feet and every 70 feet. So I can see that 50 and 70 both end in a 0, so they definitely share a 10. Let's see, 50 divided by 10 would be 5, and 70 divided by 10 would be 7. So there's my second layer of my cake. You always want to check that the second layer can't be simplified anymore. Once I realize that, LCM is when I take the L, the side, and the bottom row, and I multiply them. So 10 times 5 times 7. I'm going to do 5 times 7 first. Commutative property says I can do that, and it's a little bit easier to multiply by 10. So 350. So what is the shortest distance a runner will have to run to see both a trail marker and a water station? It would be 350 feet. Next question, Brad has collected 16 U.S. stamps and 20 international stamps. He wants to display them in identical groups of U.S. and international stamps with no stamps left over. What is the greatest number of groups Brad can display them in? So last one wanted to know the least amount of distance to get the two pieces together. This is asking the greatest, so we're looking at GCF here. So 16 and 20. What's the greatest thing they share? So they definitely both share 2 because they're both even. But when I do these questions, I try to find the greatest number I can, or a bigger number if possible. I realize that 16 divided by 4 is 4, and 20 divided by 4 is 5. Now LCM takes the L piece, but the GCF just wants the GCF and numbers out front. So we get 4. And I want to show you that even if you had used the 2, that you would still end with 4. So let's go back and say, I only taken a 2 out. So 16 divided by 2 is 8. 20 divided by 2 is 10. There's the next layer. But again, I always check that layer. They're both even, so I can take a 2 again. 8 divided by 2 is 4. 10 divided by 2 is 5. So GCF is to multiply those guys. 2 times 2 still gets you 4. So what is the greatest number of groups Brad can display them in? It would be 4 groups. All right, our next question here says a customer paid $15.40 for 1 4/10 pounds of shrimp. How much was each pound of shrimp? So each pound is unit rate, and we find the unit rate by dividing. So take the cost and break it up into equal-sized groups. All right, so we're looking at when I divide, this divisor has to be a whole number, so I'm going to scoop this decimal in one place, but I got to do the same thing over here to keep it balanced. So now the decimal is behind the 4. So I can look for, let's see, 14 won't go into 1, but 14 will go into 15 once. 1 times 14 is 14. We got 1 remaining. If I bring down this 4, hey, 14 will go into 14 1 full time. 1 times 14 is 14. At this point, we're not finished, though. We got a 0 there. So 14 will go into 0 0 times. Now we have nothing left. Now this answer is 11 and 0/10, but that's the same thing as saying 11. So the question is, how much was each pound of shrimp? It's $11 for 1 pound of shrimp. All right, our fourth question here says that Mrs. Burns has 7/8 pounds of Jolly Ranchers. She gives each student in her room after school 1/16 pound and has none left over. How many students does Ms. Burns have after school? All right, so if you think about this one, here's all her Jolly Ranchers. That's made up of 7/8 pounds. She's going to give 1/16 to this student, 1/16 to this student, and she's going to keep doing that until she doesn't have any left, and she doesn't have any left over. That's a key thing to remember. There's no remainder. So think about what operation takes a total and breaks it into equal-sized groups. It's division. So we're looking at taking 7/8, the total amount of candy she has, and dividing it into equal-sized groups. So to divide this, remember, dividing fractions, easy as pie. Flip the second fraction and multiply. So I'm going to take, let's see, there's two ways to go from this point. I'm going to start by taking 7 times 16. So that's 42. 7 plus 4, that would be 11. So that would be 112 divided by 8. So to answer this piece, I'm going to have to do some long division here, top and inside the box. 8 won't go into 1, but it'll go into 11 once. 11 take away 8 is worth 3. And 8 will go into 32 4 times exactly. So I would get 14 here. So it looks like she had 14 students after school. Now a little bit of a shortcut that I know a lot of you have been using throughout the year is if I go back to this step right here and the cross-canceling idea. A numerator and a denominator can cancel out. 8 will go into 16 twice. 8 will go itself once. 7 times 2, that's equal to 14. 1 times 1 is worth 1, so I still get that answer of 14 students. So if she has 7/8 pounds and she gives 14 students 1/16 of a pound each, she's going to use all 7/8 pounds. And our last question is just very similar to the last one, but it's just straightforward. Here's your division question. The new piece is this first part, 2 1/5. I can't divide the dividing fraction song that you use. It works for fractions and not mixed numbers. So our first step is to rewrite this guy as an improper fraction. So fifths 2 times, 5 times 2 is 10, plus 1 would be 11. So I have 11 fifths divided by 1/8. So dividing fractions, easy as pie. Flip the second fraction and then multiply. So cross-canceling isn't going to work here. 5 won't go into 8 a whole number of times, nor 11. So 11 times 8 is 88. I got 88 fifths, which is an improper fraction. So I'm going to knock it over. Top goes in the box. 5 will go into 8 once. The remaining 3 pieces will group up with these 8. 5 will go into 38, let's see, 7 times, because that's 35. So I have 3 remaining. So if I wanted a decimal, I put the decimal in and keep going, but we're dealing with fractions, so I'm going to take the remainder, and it becomes the numerator out of the, keep the fifth denominator. So 2 1/5 divided by 1/8 equals 17 3/5. And that is our third video reviewing Module 2 material. See you next time.